The moon has orbited Earth for billions of years. It controls the tides, stabilizes our planet's axial tilt, and illuminates the night sky. It feels familiar, constant, almost comforting. And yet, despite being the closest celestial body to Earth, the moon remains one of the most mysterious objects we have ever studied. Unlike most moons in the solar system, Earth's moon is unusually large compared to its planet. In fact, the Earth-Moon system is closer to a double-planet system than a typical planet-moon relationship. Statistically, this configuration is rare, and some astronomers consider it an anomaly by itself. One of the oldest and most debated questions is how the moon formed. The leading hypothesis, known as the giant impact theory, suggests that a Mars-sized object collided with early Earth, ejecting debris that eventually formed the moon. While this theory explains certain aspects of the system, it struggles to account for others. For example, lunar rocks brought back by Apollo missions show a chemical composition nearly identical to Earth's mantle. This similarity is difficult to reconcile with the idea of a foreign object contributing most of the moon's material. Some scientists argue that this coincidence is too precise to be easily explained. The moon's internal structure also raises questions. Seismic experiments conducted during the Apollo missions revealed unexpected behavior. When astronauts intentionally crashed lunar modules into the surface, the moon didn't absorb the impact like solid rock. Instead, it vibrated, sometimes for hours, earning the description that it rang like a bell. These vibrations suggested that the moon's interior is highly fractured or layered in a way unlike Earth. Later analysis confirmed that the moon experiences moonquakes, some caused by tidal stress from Earth's gravity, others triggered by temperature changes as the surface rapidly heats and cools. Unlike earthquakes, lunar quakes can last an unusually long time. This prolonged shaking implies a dry, rigid interior with little ability to dissipate energy. Yet, even today, scientists do not fully understand why the moon behaves this way. Another major mystery lies beneath the lunar surface: gravitational anomalies known as mascons. These regions exert stronger gravitational pull than surrounding areas and were first discovered when spacecraft orbits behaved unpredictably. Mascons are believed to be massive concentrations of dense material buried under ancient impact basins. However, their size, distribution, and persistence raise further questions. Why are they concentrated on the near side of the moon? And how did they remain stable for billions of years without collapsing or dispersing? The moon's rotation adds another layer of mystery. It is tidally locked to Earth, meaning the same side always faces us. While tidal locking is common in the universe, the precision of the moon's synchronization is remarkable. The near-perfect alignment allows humanity to see only one hemisphere from Earth, while the far side remained unseen until the space age. When spacecraft finally revealed the far side, scientists were surprised. It looked dramatically different. The crust on the far side is thicker, with fewer large lava plains and a heavily cratered surface. This asymmetry suggests a radically different geological history between the two hemispheres. Why did one side become smoother and darker, while the other remained rugged and ancient? Several theories exist, including uneven heating during formation or early interactions with Earth's gravity. But no single explanation fully accounts for the difference. NASA's Grail mission later mapped the moon's gravitational field in unprecedented detail. The data revealed that the lunar crust is extensively fractured, almost like shattered glass. This suggests an extremely violent past, marked by intense bombardment and internal stress. Temperature on the Moon is another anomaly. With no atmosphere to regulate heat, surface temperatures swing from extreme cold to extreme heat. Yet some regions retain warmth longer than expected, while permanently shadowed craters near the poles remain among the coldest places in the solar system. These shadowed regions hide another surprise: water ice. For decades, the Moon was thought to be completely dry. But recent missions confirmed the presence of frozen water, trapped in darkness for billions of years. This discovery reshaped our understanding of the Moon and its potential future role in human exploration. The Moon also contains localized magnetic fields, despite lacking a global magnetic shield like Earth's. These magnetic patches are irregular and unexplained. Some may be remnants of an ancient magnetic field, while others could be caused by massive impacts magnetizing the crust. Throughout history, astronomers have reported strange transient phenomena on the Moon's surface. Sudden flashes of light, glowing patches, and brief color changes have been documented for centuries. Known as transient lunar phenomena, these events remain controversial. Some scientists suggest they may be caused by gas releases from the lunar interior or by meteor impacts. Others argue that observational error or atmospheric distortion could explain some sightings. Still, not all reports fit neatly into existing explanations. Even the Moon's core defies expectations. Once thought to be completely solid and inactive, it is now known to be at least partially molten. This challenges the long-held idea of the Moon as a dead celestial body with no internal activity. The more data we collect, the more contradictions emerge. Each mission answers old questions but introduces new ones. The Moon appears simple from afar, yet complex upon closer inspection. It is silent, ancient, and close, yet it refuses to fully reveal its story. Perhaps the greatest mystery of the Moon is not any single anomaly, but the fact that so many questions remain unanswered about an object so near to us. We have walked on its surface. We have brought pieces of it back to Earth. And still, the Moon continues to surprise us. It may be familiar, but it is far from fully understood. And as we prepare to return, one thing is certain: the Moon still has secrets to reveal.